Section 5.2 Interactive Assignment Objective 2, using the general addition rule. A standard deck of cards contains 52 cards. One card is selected from the deck. In Part A, we want to compute the probability of randomly selecting a 6 or 2. In Part B, we want to compute the probability of randomly selecting a 6 or 2 or ace. In Part C, we want to compute the probability of randomly selecting a 3 or club. Okay, so here we have our deck of cards. And so for Part A, it says a standard deck of cards contains 52 cards. And so what we want to do is we want to compute the probability of randomly selecting a 6 or a 2. So we want to select a 6 or a 2. Okay, and we know that we have a total of 52 cards. Okay, now a 6 and a 2, they are separate, which means that they are disjoint or mutually exclusive. Okay, so use the addition rule for disjoint events to find the probability, because 6 and 2 are disjoint. And the rule states that if E and F are disjoint, then this is the following formula. The probability of E or F is equal to the probability of E plus the probability of F, where E represents a 6 and F represents a 2. So what we're going to do is we want to find the probability of a 6 or a 2. So we want to find the probability of a 6 plus the probability of a 2 using this formula. Now, what does that mean to find the probability of a 6? Well, that means that we need to find the number of outcomes that have a 6 in our deck of cards divided by the number in the sample. Okay, and then we want to find the number of outcomes of 2 in our deck of cards divided by the number in the sample, or the sample size. So how many 6s do we have? Well, we have 1, 2, 3, 4. So we have 4 6s, and we're dividing it by the total in the deck of cards. Plus, how many 2s do we have? 1, 2, 3, 4. So we have 4 of the 2s, and we're dividing that by the total in the deck, which is 52. Now, we can either convert these to a decimal or just combine the fractions. So if we take 4 plus 4, we get 8 over 52, which reduces to 2 over 13, because if we divide both of these numbers by 4, if we divide 8 by 4, divide 52 by 4, we get 2 over 13, which gives us 0.1538, and they want us to round the probability to 3 decimal places. So we're rounding up, so that means if we round up, this now 3 becomes a 4, which becomes 0.154. So therefore, in our first answer, the probability of a 6 or 2 is 0.154. Okay, which means that if we wanted to round this or take a look at this as a fraction, this means that if we wanted to write this as a fraction, the 4 is in a 1,000ths place. That means 154 out of 1,000 possibilities, we would expect to get a 6 or a 2. Okay, so now we're going to move on to Part B. Now, what does Part B ask us? We want to compute the probability of randomly selecting a 6 or 2 or an ace. So we're just going to use this one down here. So each 2, each 6, each ace are exclusive. Okay, they do not have anything in common. So we're going to use the addition rule for disjoint events because they don't have anything in common to find the probability. So the rule states that if E and F are disjoint or mutually exclusive events, then the following, well, we have 3 of them. So that means we're going to find the probability of E or F or G, which is equal to the probability of E plus the probability of F plus the probability of G. So what we're looking for is we want to find the probability of a 6, the probability of a 2, and a probability of ace. So again, we have the probability of a 6, the probability of 2, and a probability of an ace. And again, how many do we have in a deck of cards? Well, we know that in a deck, we know that there are 52. So therefore, that's going to be the total in our sample. So now let's write the formula down. So the probability of a 6 is equal to the number of outcomes that has a 6 in the deck divided by the total in the sample. And then we're going to find the number of 2s that are in the deck of cards divided by the total numbers in the sample. And then we want to find the number of aces in a deck and then dividing it by the number total in the sample. So let's go ahead and do that. Okay, we know again from the previous example that there are 4 6s in the deck. And we're dividing it by the total, which is 52. And then we want to find how many 2s there are in a deck. We have 1, 2, 3, 4, which again is what we found in the previous example. So that's 4 over the total in the sample, which is 52. And then how many aces do we have? Well, we have 1, 2, 3, and then 4. So we have 4 aces, and then dividing it by the total in the sample. Okay, so when we add 4 plus 4 plus 4, well then we get 12 divided by 52. Which, if we reduce this, a number that they have in common is a 4. So we're going to divide the 12 by 4, 52 by 4, by 4, and we get 3 over 13, which gives us 0.2307. Rounding it to 3 decimal places means we need to round that 0 up to a 1 because of the 7, so we get 0.231 for the probability. So in the probability of a 6 or 2 or an ace, we can see that our probability is going to be 0.231. Now again, what does that mean? That means that if we rewrite that in terms of a fraction, we would get 231 out of 1,000. So that means out of 1,000 tries, we would expect that 231 is going to give us a 6 or a 2 or an ace. Okay, now let's take a look at part C. So if we look at part C, here's part C to the right here. It says compute the probability of randomly selecting a 3 or a club. Now the difference between this one is that you can get a card that is a 3 and a club. So this is no longer disjoint or mutually exclusive. So therefore, we have to use the general addition rule to find the probability, and the rule that states that for any 2 events E and F are the following. The probability of E or F is equal to the probability of event E plus the probability of event F minus the probability of E and F. Because we cannot repeat this card twice. So we have to subtract one of them. So let's go ahead and do that. So we want to be able to find the probability of a 3 or a club. So we want to find the probability of a 3 or a club. So a 3 or a club. So that means that we want to find the probability of a 3 plus the probability of a club plus minus the probability of a 3 and a club, because that means we want to find that card that is a 3 and a club. So now what we're going to do is use our formula. So recall here that we want to find the number of outcomes of a 3 over the total in the sample plus the number of outcomes that's a club divided by the total in the sample. And then we're going to subtract, okay, the number of outcomes that have a 3 and a club divided by the total in the sample. Okay, so what does that mean? Okay, well, that means the following. All right, so we have 4 out of 52. That means how many 3s do we have? Okay, well, we have 1, 2, 3, 4. So we have 4 of them, and then we're dividing it by the total in the deck or the sample size. Okay? And then we have the following. We have how many clubs? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 divided by the total in the sample. Now I'm going to use a different highlighter here to represent a 3 and a club. Okay, now I want you to notice that we've already included the 3 of clubs in the first probability, and we included it in the second probability, which means that's why we have to subtract one of them. So what we're going to do is we are going to now get rid of that 3 of clubs. So that 3 of clubs, okay, is the following. Okay, we're going to get rid of this 3 of clubs, which means we're going to subtract that 1 over the total. Okay, so now what we're going to do is we're going to add this together. So 4 plus 13 is 17, minus 1 gives you 16 over 52. And then what we're going to do is we're going to divide and reduce that fraction. So dividing by 4 reduces to 4 over 13, which gives us a decimal of 0.3076. And rounding it to 3 decimal places means we need to round this up to 8. So it's going to be 0.308, which again means that out of 1,000 attempts, that we would expect 308 that would give us a probability of 3 or a club. And so therefore, putting our answer into my Math Stat Lab, we get 0.308 for our probability.